Lesson number 17, we have the photo switch, also known as a photoresistor or light dependent resistor, and we have a relay. So the photoresistor is used to change its resistance with varying light intensity. So it's going to read the light intensity of the room on the serial monitor. So once it reaches 400 ohms, it normally opens, the relay is closed, and the LED connected to pin 13 on the sunfire founder will light up. So let's do it. So all I need to put my finger right here. We see the LED lighting up. And then when it's gone, you see the reaction. So this is what we're getting from this circuit. And so for lesson number 16, we have photo interrupter. So a photo interrupter is a sensor with a light emitting component and light receiving component packaged face to face, and it provides a light that interrupts an object passed through the sensor. So the way we're going to test this circuit is by putting a piece of paper through the circuit, the photo interpreters. Right there. So we're gonna put a piece of paper right there. So all you have is VCC ground, of course, and then you have it connect to digital pin 8. And then all it's gonna do is when it senses a light, or not a light, when it senses a paper or anything, or object, and right there, it's going to flash on the Arduino. So let's do it. So I'm going to put the paper through. See, you see where L is. So when the paper's in, it's off. It's gone. It's on. And I can try to show you. So let's see, like this. I'm struggling. All right, in, out, in, out. So it works. All right, for lesson number 1, we have the LCD screen and we need to print a message on it. So of course we need a couple codes and we need the message. So we're going to use a string for LCD, which is going to be Sean. Sean, where is it? Sean here. And it's going to print hello world, as we have right here. And it's going to print the name of the board we're supposed to be using, which is Sunfounder. So it's like a billboard message. All right, lesson number 3 uses a Hall switch, which has 3 input, the VCC and ground, and the other one's to digital input number 8. And then we have our buzzer, of course, which uses VCC and ground, and then we have also pointing to digital number 7. So here, the Hall switch is supposed to use with a magnet, but unfortunately, I do not have a magnet. So whenever the magnet comes close to the Hall switch, it's supposed to tell the buzzer to scream, and then it screams. But can't test it because I do, like I said, don't have a switch. But that's essentially what the Hall switch is supposed to do for this circuit. But what I can tell you is what the Hall switch does in general. So a switch Hall sensor consists of the voltage regulator, a Hall element, differential amplifier, trigger, and output terminal of digital values. And when used, it's an energized conductor, so that's why it reacts well with the magnet. So here we have lesson 4. So for lesson 4, we have the analog temperature sensor. So it will sense temperature and convert it into an output signal. So it converts the analog signal into an output signal, which is digital, so for us to read. So it has 4 pins, of course, power and ground, and then we have one going to analog, so it can convert to digital at pin 7. So here we have the reading on our serial monitor. So first it reads it as raw reading, which is reading at 431. Of course, we really don't know what that means. So then it converts it to centigrade, which is 26.54. And from centigrade, converts it to Fahrenheit, and which we can read the temperature, which is 79 degrees in the room. So right now it's reading at 79 degrees. And here's our code to allow us to visually see that and read those sensors and temperature from the room. So for lesson number 5, we have the thermistor, temperature detection. So this is it right here. It has a little LED, so it can detect the temperature of the room, and we're gonna use the LED screen to print it. We could use a serial monitor, but we can also use the LCD screen, which it works the same. So right now it's reading 61 Celsius, and it's going to convert into Fahrenheit, which is 142. And we have the code to do that. So we have the code for Celsius on here, and then we have the code the temperature for Fahrenheit, which is 1.8 times temperature, to convert Celsius to temperature. And then we have that to read it on the LCD screen. And it uses the already analogs and the digital. So we have analog, of course, for the LCD screen to print it to work, and then we have our ground and power on our breadboard as well, and then we also have our digital to our number 7 from the thermostat. So lesson number 5, we have a thermostat in the LCD screen. So thermostats are what we all have in our house. It's a sensitivity temperature sensor, resistant changes accurately with temperature changes. It reads them. So this is what we're going to do. We're going to allow it to read the temperature of the room, or how it reads on the LCD screen. So here we have the LCD screen reading 60 degrees Celsius, and then 141 in Fahrenheit. So lesson number 7, we have the barometer, also known as BMP 180. It's connected. It has 4 pins. One is to 5 volts and ground, VCC and ground. And then we have the analog 4 and 5. So it's supposed to read. It's a digital barometric pressure sensor. It's with a very high performance, which enables mobile devices such as smartphones, tablets, and things of that. Boost improvements. So for this one, we're going to have it read the temperature and pressure in degrees in Celsius and in pressure from MB in inches. So here's our barometer circuit code sensor. So it's reading temperature right now 23.17 degrees and 73 degrees Fahrenheit, so it's pretty warm. And then it has a pressure of 23.8 MB, and then we have 30.34 inches, so it's not that much pressure. Here is the code that reads it and prints it to the serial monitor in the case of an error. So if it's not able to read, it's gonna print it. All right, so for lesson number 8, we have a real-time clock module. So the real-time clock module is right here, and it's going to give us the actual time of the day, supposedly. And it's supposed to be a low-cost and easy time clock to obtain the current date and time. And we're going to use it in combination with an LCD screen. So once we run the code, we have a code here, and we have a code for the pins is connected to for each one, for LCD screen and a RTC. Then for the RTC, we have to label Sunday, Monday, Tuesday for the string copy. so you can actually print it on the LCD screen. And then we also have to label the days, time, seconds, minutes, all of that using a string. And then wherever it's inputted goes in, and then here, LCD screen. So it's supposed to be year, month, date, which is Saturday, which is not, well, today is Saturday. And then the time, and the minutes, seconds, and hours. We have the flame sensor for lesson 9 and the buzzer. So our flame sensor, the way we're going to detect it is with a lighter. And when it senses a flame, it's going to make a sound to the buzzer. And if there's no flame, it's going to be quiet. So we have, for the flame sensor, it has 4 wires. 2 are connected to ground and VCC. As usual, the same for the buzzer, ground and VCC, and then for the buzzer, it's connected to input 7, output 7. Sorry, input output 7, and then we have white and brown. When it's brown is connected to, we have brown D0 is connected to to 8, and then we have A0 is connected to analog 0. So I want you to watch this. So we have our buzzer, and we have our buzzer, and we have our flame. So flame sensor. So let me get the camera right. So whenever I put a light towards it, quiet. And you can see because of this LED right here that it's working. And it has a pretty good distance on it. So, okay, so for lesson 10, we have the gas sensor. The gas sensor detects or senses any combustible gas in the air. So the way we're going to test this circuit is with a lighter. So we have 4 pins, 2 connected to the ground and power, of course, VCC and ground. And then we have 1 to analog and the other to digital, pin 7. So we also have our serial monitor. So it's going to print the state that we're in based on the flame. So I want you to watch this. So we have the flame over it. You see it's at a constant state. And then also I want you to see that when the flame is over it, the LEDs are lighting up. So it's definitely receiving and transmitting that towards the sensor. So here we have lesson 12, which is the joystick. So this is what we see on all our controllers, or anything really gaming wise. So we have red, which is VCC, 5 volts, ground, which is of course go to ground. We have a white cord going to input 7 on the Arduino, and then we have A0 brown cord is the X, and then Y is the yellow. So whenever if you look at our serial monitor, whenever I move, it's going to read that direction. So essentially Z is the middle, so it's going to turn to 0 whenever I push it down, 1 when not. When I move all the way over, this is X, this is our Y, and it goes to 1023. So now following our code, we have A0, A1, and then we have BT, which is 7, and that's for our Z. X pin is for, X is for Y, X is for our A0 is for X, and Y is for A1. And then we have to read it and to read our code and print it on a serial print from whichever is direction is coming from the joystick. So this is how our joysticks work on our gaming systems. Okay, so here we have the button. Same thing, it has 3 inputs, 3 cords, 5, 1 is for VCC, 5 volts, ground, and then we have connected to pin 7 of the Arduino. The button will be controlled by an LED, which is essentially pin 13, and it's on the Sunfire board, which is the Arduino already. And whenever the button is pushed, the LED is supposed to light up. So let's show. So this is a code which reads LED, turn on, turn off. Digital right, read the button pushing. So whenever it's pushed, see, we can see turns on, turns off. All right, so for lesson 14, we have the vibration switch. So it essentially is a switch. It has a spring, switch, or a shock sensor. It's an electronic switch which senses vibration, amplitude, and transfers the signal to a circuit. So here we have the code. It only has 3 pins. Of course, one goes to ground, 5 volts, and the other one goes to the pin number 8. And whenever we run it, it's supposed to read the shake or vibrations of it and then print it out on the screen. And in the code, we see we have our serial pin LED output, but it reads it on the Arduino instead of, so whenever we shake it, it should read it, which it is because the light is changing. But you have digital right pin high, digital right pin low. If else, it shake high, if not low. They're both input out. One is input, the vibration output, number 8. That's all. Okay, here we have lesson 15, which is the touch switch. So the touch switch is a switch that has a metal touch sensor and that only operates when touched by a charged body, and it has a high frequency transistor. So here we have the application. So we have the code and sensor. So here for this one, we don't have an LCD screen. We're going to read it from the serial monitor. So every time, so we have 3 pins, one that connects to ground, 5 volts, and SIG, which reads from the pin number 7, which will act as a feedback. And every time we touch the sensor, you see it changes 1 to 0 to 1, 0, 1, 0, 1. So whenever we touch it, it changes. And the code is very simple. Whenever sensor is touched, high goes on. If no touch, turns off. The LED turns on, which is the LED inside, and then it reads it to the serial.
Fuck you, Lucretia.
That's what you were supposed to do. Fuck her and tell everyone about it. Because if you don't remember,